So thank you for considering taking this course on machine learning with Python. I want to start off first with gaining a intuitive understanding of what machine learning is. And I want to move as quickly as possible from the slides here to doing interactive visualizations shortly in the coming videos, so that you can gain a visual and a more intuitive understanding. So what is machine learning? So machine learning, quite simply, it is a set of machine learning algorithms are computer algorithms that are trained to learn patterns from the data that they're trained on. So you give it some data, and then you're going to train this algorithm to be able to learn how to make predictions off of that data by learning patterns within that data. And so the main two types of machine learning that you see are supervised and unsupervised. You'll see semi-supervised as well, but these are the main two that you see and the ones that we'll cover in this course. So supervised learning is where you have some data that you're training your algorithm on, and the data is labeled. This could be data on a bunch of different cars, and the label could be whether they sold or not within 6 months of being put onto a lot. And so you already have that label that says, hey, this car, this is its features, it's sold within 6 months of being put on a lot. And you have some data on the other ones. These are some cars, and these are some examples of cars that didn't sell within 6 months of being put on the lot. And you're trying to use your algorithm, you're trying to train an algorithm to use the patterns in the data, the features of each one of those cars to predict whether a new car would sell within the next 6 months or not. And obviously you'd want to put cars on your lot, if you have a car dealership, that have a high probability of selling within the next 6 months. And so that's an example of supervised learning. Unsupervised learning is where the data set is not labeled, so we don't know which cars have sold within 6 months or haven't sold within 6 months. We just know that here's a bunch of cars, this is their features, and then a supervised algorithm is going to cluster them into groups based on those features. And so to give you a quick visual diagram, here's a diagram of some points that I scatter plotted. This is the first feature right here on this axis, and then the second feature on this axis. And so you can see these points naturally cluster up into three groups: yellow here, purple here, turquoise here, blue here. And you can see that, so a supervised learning algorithm, right, in a supervised learning approach, each one of these points would already be labeled with their group number. And so this one right here could be sold within 6 months. This right here could be sold within 12 months, and then this right here could be didn't sell at all. And that could be the group labels for the cars, and these could be two features of a car, like its age, and then it could be condition, rating of condition. And then what we would do is, in a supervised learning approach, what we're going to do is we're going to learn how to segment this data into three groups so that we can predict, say, a new car, whether it's going to be in each one of these groups. But in a supervised learning approach, we already have those labels, and we just train a model to learn these boundaries between the points, and deciding, okay, if a point falls in this group right here in this boundary, we're going to classify it as this group. If it falls in this segment right here in this boundary, we're going to classify it in this group. And those are classification models. But in an unsupervised learning approach, what's going to happen is we don't have those labels. We don't know whether it sold in 6, 12, or it didn't sell at all. But we do know that these points cluster up into three groups. And so we're just going to learn how to cluster them up. What we're going to do is we're going to assign points to groups, and then if we have a new car, which is going to be a new point on this plane in terms of age and condition, we're going to assign it to a group. And so that's going to be unsupervised learning. So supervised learning, you already have the labels, you're just trying to map input to specific label. Unsupervised learning, you don't have the labels, you don't know whether the car is sold in 6 months, 12 months or not, and you're just trying to cluster them into groups based off of their features. So what are some applications of machine learning? Some famous ones that I can think of are facial recognition. So for example, you could have a data set full of different people's faces, and you're trying to map them to their names. And you'll see this commonly used in buildings now, where you have to admit yourself, or you have some sort of like secure access to a building. They want to make sure that who's entering and their name is actually registered in a database, and maybe they map the face to an ID of some sorts. Airlines are using them now to make sure that your face matches the face on your passport. So that's very interesting, and is so widely used. Medical diagnosis. This could be the difference between someone surviving or not surviving. If given an image of someone's lungs, can they predict? Can the model determine if there is, a malignant or benign tumor, or any tumor at all? That could be, the difference between someone surviving or not, being able to detect cancer in the image of different body parts as well. So customer segmentation, those two, facial recognition and medical diagnosis, those are supervised learning approaches. An example of unsupervised learning, we learned about the cars data set where we're just clustering the cars up into groups based on their features. And another one is customer segmentation. If you run a business and you have a bunch of customers that are using your site, or they're coming into your shop and buying certain products, they're usually exhibiting certain types of behavior. You have some customers on your site that like to view certain web pages, and some that like to view other web pages. And you can cluster those customers up into different groups and market different products, or run different ads targeted at those customers that increase the chances that they're going to actually convert. And so customer segmentation is pretty powerful. It allows for you to get more return on your marketing spend. So time series prediction, this is a supervised learning approach, and this is a regression problem. So we talked about classification in our last example, but regression is a huge part of supervised learning. So is classification. So time series prediction, you think of like predicting the temperature outside in a particular area, stock price prediction, and other time series. You could be predicting the blood sugar of a diabetic patient over some time. And so what you're given as input, your input's not an image in this case, it's actually a sequence of, let's say, temperatures from the previous day or over the previous hour, or the stock price for a stock or set of stocks over the past week or month, or over the past day, if you want. And you're trying to predict future events. So you're trying to predict, given the temperature over the past 30 days, predict the temperature in a place over the next day, or over the past several years. So it's like you're inputting a sequence of data that's ordered by time and trying to predict the sequence in the future. House price prediction is not a time series. It can be a time series problem, but usually you'll see you're given the features of a home, and then you're asked to predict the price that it will sell at. And what you do is you have a bunch of data of homes that have already sold in the area, and so you have the features of each of those homes, you have the prices that they sold at, and so you learn patterns from the data, and then you get a new home that just got listed, and what you want to do is, given the features of that home, predict the price that it will sell at. And so that's obviously pretty important if you're in real estate or you're a home builder. And these are some really common applications of machine learning. Let's hop into really understanding how a machine learning algorithm works under the hood by looking at some visualizations.